Hey there, today we're diving into a fascinating world of neurochemistry where tiny molecules and complex systems team up to keep our brains and bodies humming along. Let's start with tryptophan. Yes, the essential amino acid found in turkey, chocolate, and many other tasty foods. When our body decarboxylates tryptophan via amino acid decarboxylase, it transforms into tryptamine, a key player in mood regulation and neurochemical signaling. Tryptophan doesn't just hang out in the brain, it also interacts with serotonin receptors, influencing mood, sleep, and even appetite. But beware the monoamine oxidase enzyme can break down tryptamine and serotonin, regulating their levels, but sometimes leading to a buildup that can be neurodegenerative or neurodevelopmental issues. Sometimes these imbalances contribute to psychiatric disorders, making neuroscience a real balancing act. Speaking of balance, did you know that our gut bacteria produces tryptophan metabolites that can influence the central nervous system and peripheral nervous system alike? It's like a tiny bustling metropolis of microbiome traffic controlling everything from lipid metabolism to immune responses. Some gut-derived compounds can activate receptors like Tryptamine associated receptor 1, affecting everything from neuroinflammation to behavior. Now, in the world of toxins, xenobiotic compounds like dioxins can hijack our cytochrome enzymes, leading to cell differentiation issues, immune responses, and even liver inflammation. These real chemicals can activate the hydrocarbon receptor, a cytoplasmic ligand-induced receptor, setting off a cascade involving the hypoxia-inducible factor 1 alpha, especially under hypoxic conditions, which can be quite damaging. On the cellular front, the blood-brain barrier, thanks to tight junction proteins like claudin 5, protects the brain from unwanted invaders, but sometimes viruses or inflammation can cause gaps, letting things like cytokines and bacteria cross over, leading to neuroinflammatory responses. Microglia, or brain's resident immune cells, can switch phenotypes from pro-inflammatory to anti-inflammatory, depending on signals from short-chain fatty acids produced by gut microbes. All these processes are interconnected, creating a delicate dance between chemical signals, immune responses, and cellular health. Whether there is neuroinflammation, neurodegeneration, or the gut-brain axis, understanding these mechanisms helps us appreciate the complexity and the humor of life's tiny molecular ballet. So next time you enjoy a delicious meal or marvel at your brain's resilience, remember it's all happening behind the scenes in this incredible biological symphony.